Good morning, everyone. As part of Energy Awareness Month, the St. Lucia Bureau of Standards is pleased to present this webinar on energy efficiency in buildings. We have had a significant energy portfolio in terms of standards development, culminating with the Energy Efficiency Building Code and the soon to roll out Caricom Energy Efficiency Labeling Pilot Project. Today, this webinar seeks to highlight the significance of energy efficiency in buildings, and we have the distinct pleasure of welcoming our presenter, Mr. Zephrinus Churchill Norbert. Mr. Norbert is an engineer with areas of specialty being electrical engineering, energy management, renewable energy, project management. He has worked in the energy industry for over 3 decades in Caricom and internationally. He is the founder of and managing director of Energy and Engineering Consulting Services in Antigua. He's a graduate of the University of Technology in Jamaica. He's a certified energy manager. He's a certified photovoltaic practitioner and a certified hospitality facilities executive, and holds a Master's of Science degree in project management from the University of Salford in Manchester. He's an active member of the Association of Energy Engineers based in the USA. He is the chairman of the National Electrotechnical Committee in Antigua and Barbuda and represents Antigua and Barbuda on ISO Technical Committee 301. He was the former chair of the regional project team, which developed the 2018 Caricom Energy Efficiency Building Code. Mr. Norbert is also an adjunct lecturer at the University of the West Indies Open Campus in Antigua, and we have the distinct pleasure of welcoming him. He is a national of St. Lucia by birth and has made Antigua his home for the last 20 years. So I would wish that you join me in welcoming our presenter today, Mr. Zephrinus Churchill Norbert, who will take us through our exciting topic of energy efficiency in buildings. As just before he joins, part of our housekeeping, if everyone can keep their mic muted, and we will have a significant portion of question and answer at the end of the presentation. Thank you. Mr. Norbert.
Thank you, Mr. Emmanuel. And good morning to all the participants. And I just want to, first of all, thank you for this warm welcome. And it's very good to be, again, in dialogue with my fellow country people in St. Lucia. And the work that the Bureau is doing in terms of recognizing the significance of being good stewards to the environment and to build on the work that most of the professionals who have gone before us, to recognize the importance of continuing that work. So let me commend you as well, Mr. Emmanuel, and your team for putting this initiative together, where we can come together as professionals to collaborate, discuss, share ideas on very important topics and things that are relevant not just to us, but most importantly, relevant to the future generations. So with that said, we are aware that COP26 is going through the second week right now, and there are quite a bit of discussions happening. We do have our heads of governments and other professionals who are currently negotiating and discussing some of what we'll be sharing today. So from a global perspective, the whole world is currently focusing on ways on which we can sustain our environment and to preserve the future so that our children and our children's children will continue to enjoy what we currently enjoy today. So as I begin my presentation, or continue with my discussion, I just want to remind all of us, why we are here and why do we do all of what we do in terms of the environment. And, it takes a lot for most of you to take time from your busy schedules to be here this morning, and as well, all the work that has been done and continues in terms of what we are doing to save the planet. So this slide really speaks about no plan B. And I'm sure most of you would have heard about the fact that there's no plan B. So we have to do everything that we can to sustain this planet that we have. Now, in recent times, you would have heard about most of the climate change activities. And if I go through a list of climate change activities as far as what is going on, you have the droughts, hurricanes, floods, earthquakes, volcanoes, health crisis, food shortage, water shortage, and intense fires. And these are not events that are foreign to us. These are events that we experience even in St. Lucia and in the Caribbean region. Very, very intense climate change activities. The scientists have been saying this to us for a very long time. And more we are seeing that it is time to act. It's time to act, and it's time to do things that we should have been doing for a very long time ago in order to preserve the planet, because there is no planet B. Some of the statistics as far as the realities on the ground, what the science has been saying to us in terms of the declining ice mass in Greenland. You can see from 2002 all the way up to 2018 or 2020, the reduction in the ice mass. And all of this is as a result of climate change. So, a picture says 1,000 words, and these are the realities. These are what we should be reminded of when we seek to implement policies, standards, best practices to save our planet. So how does climate change affect Earthlings? And that speaks for itself. At the heart of what we all experience right now with the pandemic, the health situation, I spoke about extreme weather events, infectious disease, water. In St. Lucia, I know that you've done 1 or 2 water projects in the Dennery area and trying to see how you can provide or to improve infrastructure to provide clean and affordable water to all, especially the most vulnerable. Mental health. So there is a strong correlation between the health crisis that we're currently faced with and climate change activities. Allergens, heat stress. Once again, these are not activities that are foreign to us, but very much we face these conditions on a daily basis. And I'm sure you may have examples of situations where you may have lost your property, you may have lost a loved one due to some of these climate change activities. Air pollution, okay? We'll speak a bit more about that in terms of the greenhouse gas emissions. Food I spoke about, places like Africa and other developing countries are suffering severely in terms of the food shortages. More and more we are told to try to sustain ourselves as far as being able to provide the food that we need. Supply chains are in serious challenges right now in terms of not being able to get our supplies on time and the risks as far as the quality of what we get as well. And extreme weathers, I spoke about this. So we see here the reality on the ground in this decade of action, 2020 to 2030, has been declared as a decade of action and things that we need to do in order to save our planet and to provide our children and our children's children with a much safer environment. And it's not that...
Алло, блядь, мужик, как слышно нахуй?
It's not that we cannot do as small island developing states. One may ask a question, what it is that we can do to make a difference? The whole idea of, climate change and how it affects our lives. And I made mention of the every step in the direction of being more sustainable is a good step. No matter how small it is, anything we can do, even within the small island developing states, it is significant. So globally, floods and extreme rainfall events now occur 4 times more often than what it used to be in 1980. So we've seen that, and we can really attest in St. Lucia that you've seen the extreme rainfalls, the extreme flooding that's taking place. And so all of the data is available to us. So now the question is, what are we doing in order to reduce the negative impacts of climate change and to be able to secure the future for our future generations? If we look at the economic losses from extreme weather conditions, just between 2017 and 2018 alone, the economic losses was in excess of 600 billion in that 1 year period, 2017 to 2018. So it's costing us quite a lot. Statistics also that was released as far as the COVID-19 and the costs so far is in excess of $14 trillion. So all of these things are costing us. And some of our leaders at COP26, they have made an appeal to the industrialized community to compensate us for the losses that we have been incurring and that we cannot afford to adapt and to make the changes on our own. Yeah, so the economic losses, that is known to everybody. So the statistics and the information that we have access to will further increase our reasons for doing the right thing. Okay. We have lost more than half of the animals on our planet in the last 40 years. Okay, so I'm just trying to create this connecting the dots with the negative impacts of climate change, not just on the economic front, but as far as the ecosystem is concerned. We have seen that most of our animals, our indigenous animals, have disappeared. The populations of marine vertebrates declined 49% on average from 1970 to 2012. So again, it is to remind us that the reason why we're here and the reason why you're doing all what you're doing is because you're focusing on making a contribution that will bring positive results for everyone in the environment. And of course, there's this common Chinese phrase that we are choking on our own success. Where you see that the average expected lifespan in northern China declined by 5.5 years. Okay, so these are some of the things that I just wanted to, again, give you a good reason why, or to remind you why we're here and why it is that being involved in such discussions would be very much beneficial as far as working together, both private and public sector entities. And again, commending the Bureau of Standards for having this webinar where we can further remind ourselves of why we are doing what we are doing and what it is that we are seeking to achieve at the end of the day. So some good news. In 2010, renewable investments exceeded those in fossil energy for the first time. Global investment in energy projects, we see that they were 187 billion compared to fossil projects of 157 billion. Now, who buys clean energy and low carbon development? Out of 391 billion invested in 2014, the public sector had a total of 38% of that investment. But a huge amount of the investment came from the private sector. So the private sector, they're the ones who are showing the most interest as far as buying clean energy interventions and low carbon development. In the region, the very same thing is true. The private sector, they have demonstrated a very high interest. And in some cases, there are some, or the absence of policies and regulations that would facilitate a greater participation of the private sector when it comes to clean energy interventions. based on our discussions in the region, and of course in St. Lucia, if you speak to any of the private sector entities, they have demonstrated quite a very high interest in moving towards clean energy and low carbon development, not just because of the economic benefits, but there are also social benefits and tremendous benefits to the environment. Under the umbrella of sustainability, the environment, the economic, and the social benefits from moving towards sustainability. Investment in new energy generation capacity. So what we see here is, as a result of all the work being done internationally by organizations like IRENA, we have the International Energy Agency, we have as well regional bodies like the Caricom, CrossQ, and of course national organizations like the Bureau of Standards, the different ministries of energy. All of these entities come together to bring about some of the results that you see here. So investment in new generating capacity, when you compare fossil fuels to renewable energy, from the year 2009 to 2017, we see a significant improvement in investment in renewable energy as compared to fossil fuels. And that is on a global context. In the region, we see the very same things happening, but there are barriers that we still have to overcome. Challenges as far as the financial access to finance, capacity building. But this is encouraging because of the trends and what we see, commitments that have been made that have resulted in an increase in the investment as far as renewables is concerned. I just also want to share some news that I got this morning from COP26, where there were new commitments made from the UK, Spain, Japan, Australia, Norway, Ireland, and Luxembourg, in addition to plans to deliver 100 billion annually to developing countries to facilitate climate adaptation measures. So these adaptation measures and these commitments, and this is coming out fresh from the discussions that are currently going on in Glasgow with COP26, where the developed countries, they have pledged to deliver 100 billion annually to developing countries like St. Lucia to facilitate climate adaptation measures. And that refers specifically to our buildings, to our roads, to our infrastructure, the things that we need to do to build resilience in our buildings. Energy efficiency in buildings, of course, is an adaptation measure. And so the global community is demonstrating their commitments towards assisting us. Now, when it comes to energy efficiency in buildings, we've had quite a bit of discussion throughout the region as far as the benefits to be derived from moving towards net zero energy buildings. There are concerns as far as cost, but we've always looked at it from the perspective of looking at the full life cycle of buildings. So whereas you may have the initial construction and design cost, upfront cost being higher than a conventional design and construction for buildings, this phase of our buildings is only between 5 to 10% of the life cycle of the building. So construction and design typically would take 1, 2, or 3 years at most. But when you come to the operations and maintenance phase, this is what most building owners, if you're going to build a new home or you're moving in towards building a new business or some infrastructure, you may not see the O&M at this time. The upfront cost that you are exposed to is in the design and construction. So you will see an increase based on the measures based on the materials, based on the design. A green building typically would have an increase in the upfront cost. But looking at it from the life cycle, the entire life of that building, where we know buildings would last between 50 to 70 years, and 60 to 85% of that is the operations and maintenance. This is where you have to think about your energy cost on a daily basis. This is where you have to think about the maintenance and repairs on a daily basis. So when buildings pretty much are designed to be net zero buildings, energy buildings, or green buildings, the true benefits would be derived from the operations and maintenance phase, because that's the longest phase of any building. So some of the discussions that you will have about, well, it's going to cost more, you need to look at it from the life cycle analysis of the entire building to really justify why it is you should go ahead with the net zero energy building as compared to the conventional designs. So what we've seen is that there is a need for policies and support from the public sector to provide incentives such as duty-free concessions. You may have other programs in St. Lucia that policies that could be developed to assist property owners with the additional cost. And that incentive would provide tremendous benefits, as I said, when you move towards the operations and maintenance and the renovation and demolition phase of the building. And this information is coming from the Ashrae HVAC Appliance 2011. So as we speak about energy efficiency in buildings, and some of the feedback that we've received based on our consultations, and Mr. Emmanuel, who was also the vice chairman of the original project team that developed the energy efficiency building code, the greatest concern was the initial cost. Another concern was the construction materials, whether or not the type of windows, the insulation that's needed, if it's available to the local consumers. But this is where, as I said, policy can really help to alleviate some of the financial burden or that increase, that incremental cost of a green building as compared to a conventional building. Now, as we discuss further in terms of the designing of the net zero energy buildings, this slide gives you a clear indication as far as the starting point, the best approach as far as being able to get to a low energy use building is to look at your current standards. And I specifically refer to the Energy Efficiency Building Code. And I know at St. Lucia you have adopted it as a national standard. So congratulations for doing that. So the first place would be to go towards your building standards, your energy efficiency building standards, your labeling standards, and during the design phase, from inception, to have that discussion, bring in the professionals, the architects, the engineers who are qualified to assist you in designing your building to incorporate the standards and the codes that exist locally. You may even decide to go above the code requirements. You may decide, if you have the correct team with you, to build and design that building so that you are incorporating the national standards, the building codes, to include the best practices in your design and construction. And at that first stage, we see a sharp decline in terms of the solutions that could be derived, the passive solutions, some of the prescriptive solutions as well, in having the next step, which is a low energy demand building. So you reduce your carbon footprint. You reduce your energy demand, you reduce your carbon footprint. How is that possible? So we know that every unit of energy that is delivered to you at your facility, at your home, every unit of energy, there is an associated carbon dioxide or greenhouse gas emissions that the power company would have to emit into the environment. So by lowering your energy demand, you are effectively lowering your carbon footprint. So if you, for example, would have used in a conventional building before applying the standards and the codes, if you would have used, for argument's sake, 100 kilowatts on a daily basis, 100 kilowatt hours, because energy is a function of time, 100 kilowatt hours on a daily basis. But after you've designed your building in such a way that you are more efficient, the building is more efficient, you have reduced your demand, then you could see that you can significantly take it down to as low as, reduce that initial demand significantly so that you are now operating at a low energy demand. The next step would now to look at the active solutions and controls. So these passive solutions could be things like the building orientation, how you orient the building, how you have shading. Are you using the shading of the building to protect the windows, especially the windows that are exposed to high intensive heat? The design of your roof, is it a cool roof with a high albedo? All of these are passive solutions. So you focus on even the low cost interventions before you get into the active solutions. So passive solutions can get you as the first step. Then you move to the active solutions and controls. So this is where we talk about a building with a low energy use based on active solutions and controls. Examples: you may have motion sensors, you may have the zones that are controlled by thermostats, you may have the mechanical systems based on efficiency ratings that are in the code or in the standard. So the coefficient of performance of the air conditioning units, the whole question of ventilation as well, when you look at your CO2 sensors. So these are active solutions that can help you to further reduce your carbon footprint. So moving from this initial, what we have in our conventional buildings, the significance of these standards, and specifically the energy efficiency building code, we see that proportionally the passive solutions can play a significant role. And then the active solutions and controls to take you further, reducing your carbon footprint. At the beginning of my presentation, I shared with you some of the reasons why we need to do this. I shared with you some of what is happening in reality as we speak on the ground. The wildfires, the floods, the ecosystem is totally out of balance. We have interfered with the habitats. So mankind is getting much closer to animals and to the species that are out there. And this is one of the reasons why, even with the current pandemic, is that we are getting closer. We have destroyed the habitat. And so we're getting closer to living with the animals and everything else, because we're destroying, cutting down trees and not paying attention to what the environmentalists are saying to us. So all of that is affecting the environment. And so when we think about reducing the carbon footprint of our buildings to be more efficient, that means we are now reducing the amount of greenhouse gas emissions that will cause all of what I said to you at the beginning. The earthquakes, the volcanoes, the floods, the hurricanes, intense flooding, water shortage, food shortage, all of these things. And the truth is that in St. Lucia, I've seen where there are many initiatives by the government. When I say government, I mean across the board, to seek funding to design projects where you look at the food systems, where you look at the ecosystem, and projects that are designed to really provide the funding and the assistance to assist in these key areas that I spoke about. Your waterways, your roadways, the health crisis, looking at the health sector as well, the polyclinics to be built, all these things that are happening, where the public sector is seeking assistance from the international community, and even regional organizations like the CDB and all of these organizations, the banks, where they have access to grant funding to assist in building the resilience in all these key sectors. So as we implement the energy efficiency building code and we focus on energy efficiency in buildings, buildings consume quite a bit of energy. We spend most of our lives in buildings. And so as we reduce our carbon footprint, as we focus on even things like ventilation in buildings, then we are really moving in the right direction as far as creating a sustainable environment for ourselves and for our future generations. And the final step, after you've gone to this low energy use building, the final step is renewable energy. So you may ask the question, why at this stage to incorporate renewable energy? Why isn't renewable energy the first step? No. In the energy industry, we say that energy efficiency is the first fuel. Energy efficiency should be applied first, and then renewable energy. What are the benefits to be derived? So if you look at this as a representation of the carbon footprint or the energy demand of a building that has gone through the passive solutions and the active solutions, and now you've reduced from a conventional building, the demand, compared to a low energy use building. The size of the renewable energy system that is needed for this building is way less than what you would need at this stage before you'd have applied the energy efficiency and the energy conservation measures. So at this stage, it's more affordable. You may have the space on your rooftop or in your yard to install the PV array. And so it is best practice to incorporate energy efficiency, energy conservation in your building, whether it's your home or your business place, and then to incorporate renewable energy, which would make it more affordable, more realistic as far as the space requirements for that system. So having said all of this, I'm going to now focus a little bit more on the Caricom Regional Energy Efficiency Building Code. So the table of contents, some of you may be familiar with the code because we have done quite a bit of training in the region as far as the Caricom Regional Energy Efficiency Building Code. In Antigua and Barbuda, we have adopted it as a national standard. So we refer to it as our National Energy Efficiency Building Code, the NEBEC. And so the table of contents, first of all, the commercial, then we have the residential sections. The first chapter looks at scope and administration. So this is where you look at the different administrative duties, who would be responsible for what. So your building authorities, your building officials would be responsible for receiving your applications, reviewing your applications. So it depends on how it's set up in St. Lucia, where you may have the Bureau of Standards, because you may have adopted it as a national standard. So now it's voluntary. And so there is the section that deals with the scope, what it entails, and the administration of that code. The code has to be maintained every 6 years. So it was issued in 2018. So 2024 is the period by which we will look after updating the standard. So it's not a static, it's a very dynamic document. The second chapter, chapter 2, that's where all the definitions, because in using the code, you have to refer to code language. What is specific to the code? As far, for example, envelope, you may hear the term envelope. Envelope could mean anything, but it is defined in the code. So to guide you as far as what is the envelope of that building, what does it entail? And so you can figure out what the requirements would be. So all definitions would be in Chapter 2. And the commercial and residential would have the same, but it's just that the requirements would differ from commercial or residential. Then we go to the general requirements. In the general requirements, you will have the climate conditions, the climate zones. So this focuses on things like, the climate zone and the requirements for that specific climate zone. Chapter 4, the specific energy efficiency requirements for that commercial building or for the residential building. So everything in terms of the envelope, the mechanical systems, the lighting systems, the compliance options, everything now is focused in Chapter 4. This is where you will receive all of the requirements in order to demonstrate that your building is in compliance with the code or in compliance with the standard. Very important. So you'll be spending quite a lot of time figuring out if it's a commercial building or a residential building, what are the requirements based on the code. And these requirements are minimum requirements. So there are instances where you may decide as the property owner or the project owner to exceed the requirements. Okay, they are minimum requirements. The development of these requirements came after decades and decades of input from professionals like yourself, engineers in the field who have been there for quite a long time working in this area would see what the best practices are. And so this is a collection of best practices providing you with the minimum energy efficiency requirements for your specific building. And that is like for your new construction. Chapter 5 looks at existing buildings. Most of our buildings that exist today, they also need to be more efficient. So you will also find provisions for your existing commercial building or your existing residential building. And Chapter 6, the reference standards. So a lot of standards, all the standards that are referenced, that are used in the code are referenced, they're listed in Chapter 6 of the Energy Efficiency Building Code. You can gain access to this through the Bureau of Standards. If you have not seen it as yet, you can speak to Mr. Emmanuel and his team. They'll be able to share with you information pertaining to the actual document. How can you purchase it? It can be purchased online from the International Code Council. They do have hard copies as well that they can share with you. So you do have access to the code. Then the appendix, there's an appendix for the solar ready provisions for commercial and the solar ready provisions for residential. What it speaks about is that you have the provisions made for renewable energy. It's not compulsory that you should have it, but if it's a new construction, you should have provisions made for a renewable energy system on your rooftop. So you would design the roof, whether it's south-facing roof, and the size of your system, if it's an average of 5 kilowatts for your residential, and depending on the regulations in St. Lucia, what is allowed, you can make provisions for that. So the code looks at renewable energy as well, not just energy efficiency, but as well at a minimum to make provisions for your renewable energy. In the commercial sector, it goes a step further to give you an additional option if you would like to factor in renewable energy into your building. For commercial buildings, you can take that further to go about using renewable energy as an additional option for your commercial building. And then, of course, the index. So this is basically what you will find in the Caricom Regional Energy Efficiency Building Code that you have adopted in St. Lucia. So I'm hoping that all of you are aware, because this webinar is also an awareness exercise to share with you some of what exists, some of the work that you have done in St. Lucia and that you continue to do as far as energy efficiency is concerned. There is also the Ashrae 90.1 2016 standard. So the entire standard is in that document. That is why it is very thick. It's about 1 inch thick, because you have in there the entire Ashrae 90.1 2016 standard. And this is there because it is an additional compliance path for your commercial buildings. So if you're designing a commercial building, you can use the Ashrae 90.1 2016 as your compliance option. Now, I said before that the code was adopted as a national standard, so it's voluntary, but you can definitely demonstrate and engage in discussions to utilize it. There are people who are thinking about utilizing this code and that they could be recognized for having an energy efficient building. What is the intent of the Caricom Regional Energy Efficiency Building Code? What are we seeking to achieve? The first one is that it is really to conserve energy over the useful life of the building. Conserve energy over the useful life of the building. And I shared with you a few moments ago that useful life, the O&M, operations and maintenance phase, that you can't really see because it's a new building, you're just starting off, or you're just designing the building. But you're conserving energy over the useful life of that building. And that could be 50, 70, in some instances more. So this code, when implemented in a building, focuses on the longest phase as well, which is the operations and maintenance phase. And that's where the true savings can be derived. The other intent is to provide flexibility for innovation. So you could now have a building that is very flexible, that is responsive, that can adjust in terms of, for example, occupancies would vary from time to time, and that building can have the technology to understand that there's no one in the building, so the air conditioning system should not be on. So this is a very flexible building, a building that can be very smart, all right? Smart in terms of monitoring, in terms of sensing, in terms of providing the air quality that you need, all right? Knowing the CO2 content of your building and having that CO2 sensor to come on, to turn on your extractor fan at 100 parts per million, for example, of CO2 in the building, and to switch off the extractor fan when you get down to like 300 parts per million of CO2 in your building. These are in keeping with Ashrae standards and other reference standards. So there are very good control systems to help you save energy, improve the quality of the occupant comfort, and build the resilience of our buildings. And when we do all of this, as I said earlier on, we are effectively reducing the carbon footprint of our buildings, reducing the amount of greenhouse gas emissions of our buildings. And thirdly, the code is not to abridge safety or health requirements from other laws and regulations. The code as well recognizes other above code programs, such as LEED. In St. Lucia, you may have, I think there's a LEED building next to the marina in St. Lucia. Antigua just built its first LEED building as well. It's an interpretation center. So more and more, we are seeing that people are involved in above code programs such as LEED. So the code recognizes that as well and allows national or local energy efficiency programs as alternatives, but there are some requirements that they must be approved by the code official or the authority having jurisdiction, and the mandatory requirements of the CREBEC must be met. So these mandatory requirements are great opportunities to save energy and to conserve energy in buildings. For example, insulation, your insulation for your mechanical systems as well, windows, fenestration issues, air leakage. There are mandatory requirements surrounding these parameters in our buildings. So yes, if you're thinking about building a LEED building in St. Lucia, some of you may be involved in these programs. The code welcomes that, and there are, as I said, the two points to note is that it must be approved by your code officials, and as well, you must meet the mandatory requirements of the Energy Efficiency Building Code. So the information on construction documents, I made mention of insulation, very important. So for example, you'll have to identify the R values of your insulation, and you must meet the requirement of the code. Fenestration, we talk about the U factors, the thermal conductance of your windows, the solar heat gain coefficients, or the SHGC, very important. The area weighted U factor and the solar heat gain coefficients calculations. All of this information must be available on your construction documents. The mechanical system design criteria. Are you zoning your property? Do you have programmable thermostats per zone? And these programmable thermostats must meet the requirements of the code. I spoke about smart buildings, flexible buildings, where you can have very smart thermostats that are programmable. So you're not just relying on the human person to turn off the AC, but using control systems to do that. Mechanical and service water heating systems and equipment types, the size and the efficiencies. So mechanical would cover all of your HVAC systems plus the service water heating. So you can see here that the code is focusing on key areas within our buildings where there are opportunities to use both passive and active measures to reduce the carbon footprint and the energy demand or energy intensity of our buildings. Equipment and system controls. All right, system controls like lighting. You can utilize daylighting by having the daylight responsive systems. You can have the photocells. You can have timers. So there are many opportunities, but keep in mind that as you utilize the code, what is provided in the code are minimum standards. Duct sealing, duct and pipe insulation and location, very important, because you may spend, the project owner may spend an enormous amount of money buying the most efficient equipment, for example, the most efficient air conditioning system, but your ducting system that transfers the conditioned air from one location to the other, if it's not properly insulated, then you're defeating the purpose. The same thing for pipes. If you're distributing the fluids and they are not insulated properly, then you could miss the point in terms of being as efficient as intended. And finally, air sealing details. The envelope of the building should be designed in such a way that ventilation is intentional. Intentional by designing it that way. What amount of ventilation do you need? I made mention of the carbon dioxide sensors in buildings. That is intentional, but not through leaks where the envelope is very leaky. That can cause serious problems where you have condensation in buildings, you have mold in buildings, you have the occupancy. The occupants are very uncomfortable when these things happen. So your envelope has to be tight, and then ventilation is by design. So we look at the flexible compliance options, which is a very important element of the code. The code is a very flexible code because of the compliance options. So there are 5 commercial compliance options, and for the residential, 5 options as well. You can demonstrate compliance. I made mention of the Ashrae 90.1 being one of the options for compliance for commercial buildings only. You have the prescriptive and performance. This is where you could utilize software. So yes, you can demonstrate compliance by using software, okay, to model the building and to compare it against a standard design. So you have a standard design and your proposed design. What is the annual energy cost of your proposed design? It must be in line or lower than the standard design. For your residential buildings, there's also a prescriptive compliance path. There is a total UA alternative, performance, and the energy rating index. So you see the performance as well, we utilize software, and the energy rating index also utilizes software for residential buildings. So you have prescriptive measures if you decide to go prescriptive, looking at things like your U factors, your insulation values. These are prescriptive. And performance would be using software to model the building. This just gives you an example of what the options I spoke about for your residential buildings. So you have the simplified compliance path, where you can now follow this depending on your design. You could use a simplified path to go straight to the code, to the plan reviewer. You can get your plans approved, or you can begin construction, inspections, and a certificate of occupancy. That's a simplified path for residential buildings. If you're using the prescriptive, I said you would be looking at your R values, U factors, and the total UA. So that's the prescriptive requirements for your residential building. And if you're using software, there are two options: the simulated performance alternative or the energy rating index. So you can model buildings. A lot of us are using modeling, especially with buildings today. That's the best practice. You can actually demonstrate to the property owner or project owner what the outcomes would look like even before the building is built. So a lot of people are moving towards building simulations and modeling to achieve this benefit as far as your design. So it's referred to as the alternative compliance path, where you use software, or prescriptive, where you think about your insulation and the U factors, or the simplified version. The simplified version, it's pretty much most of our residential buildings in St. Lucia and in the region can use the simplified version. About 80% of our buildings will be able to use the simplified version for compliance, simply because of the fact that not the entire building is not air conditioned. So this, to meet the requirement for the simplified compliance option, is basically to say that your building is less than 50% air conditioned, and that you're using some form of renewable energy for your water heating, and that would pretty much be some of the main, and it must be of a particular size. And once you could demonstrate that your design would meet the requirements of this compliance option, then you could use it. It's very simple. A checklist can be used for that. And so for the commercial as well, I'll be finished in just about 5 minutes. We'll be able to have some questions and some discussions surrounding what I've shared with you. For commercial buildings, this is a compliance path where you have the prescriptive sections, or you can use the total building performance using software, or you could use the Ashrae 90.1. So these are the three main areas that you can select for your commercial building. So the first thing you would decide to do is to have your commercial building, your compliance path selected, so you know which one. So if you've selected the prescriptive, then you have to follow the building envelope requirements, the mechanical requirements, the water heating requirements, the lighting requirements. And I spoke about the additional efficiency options. One of these options would be to increase the use of renewable energy to demonstrate compliance with the code. And then you have the commissioning, which is very important in our buildings. This is very much lacking today. Most of our buildings have not been commissioned. So utilizing this code helps you to focus on commissioning as well. So all of these requirements would have to be followed if you have selected the prescriptive compliance path for your commercial building. If you're using the total building performance option, there are mandatory requirements that must be met, and as well the performance requirements for your proposal against the standard design. And Ashrae 90.1 is another compliance option. So this is it for the commercial buildings. For Ashrae, the compliance would look at the mandatory provisions and the sections where it could be found, the prescriptive building envelope requirements. There are submittal requirements within the Ashrae 90.1 and the respective sections where you can get it in section 5.7. And section 5.8 looks at the product information and insulation requirements. So product information would be like, the windows, fenestration, the efficiencies, and the installation requirements based on the requirements found in the Ashrae standard. So if for your commercial building, you can just follow the Ashrae 90.1 to demonstrate compliance for your commercial building. just to give you some information about the thermal envelope, this is what it would look like and how you should demonstrate to your code officials what the envelope is. It should be sealed, it should be shown on the plan, and you should test it. So just some basic information about your solar heat gain coefficient. This is the most important performance characteristic of fenestration in hot climates like ours, the solar heat gain coefficient. And this image demonstrates what happens if your windows are not high performance windows. Quite a bit of radiation heat can enter the building and affect the cooling loads of your building, increase the demand for cooling, and thereby increasing the use of energy. So just by having your windows meeting the requirements as far as the solar heat gain coefficient is provided, based on what's provided in the code, can be very beneficial. I spoke about your roofs. So you have what we call the cool roof concept. So roofs with high albedo, and of course the insulation values of R2.3, or in the absence of that, you can use the R3.3 if you do not have the design as a high albedo roof. This is an example of fenestration requirements, the U factors I spoke about. There is the National Fenestration Rating Council, the NFRC. They provide this, the windows that they provide would meet the requirements of the code. So in going out to procurement, you would try to source the NFRC windows, or pay attention to the U factors, the solar heat gain coefficient of your windows. So that's just an example of what your label should look like for your windows. For the blower door depressurization test, I spoke about the envelope being tight. So there's what we call the blower door test, where you would have to test the tightness of the envelope to demonstrate that the envelope is tight, especially for commercial buildings and for residential buildings where the entire building is air conditioned. If it is that 50% or less of the building is air conditioned, then you don't need to do this blower door test, because you are part of the requirements would be that if it is not more than 50% of the building, then you don't need to do the blower door test. But for commercial buildings and residential buildings where you have over 50% cooling, then you are required to do this blower door test. I just wanted to share with you this example here of results from a recent study in Antigua and Barbuda, the summary of energy efficiency and renewable energy projects at a public facility. So quickly, we see here that the no to low cost energy efficiency measures, there were tremendous savings in CO2. The initial cost, no initial cost. I just can't see this thing clearly, but this thing's blocking my, okay. The annual savings in US was tremendous. When you look at the simple payback period, not applicable because it was a no cost measure. But just by doing, very low to no cost measures, the amount of savings in CO2 and the financial savings as well. The capital projects, energy efficiency capital projects, the annual CO2 savings, the initial cost, and the annual savings. The payback period, 1.7 years. But when you look at it compared to renewable energy, the savings in CO2 was just a little bit over what we got from the energy efficiency interventions, but the initial cost was much higher. And as I shared with you before, that was because when you implement renewable energy projects before doing energy efficiency in your buildings, then typically the size of your system and the cost of your system would be much higher. And this is demonstrated in this case study that was done in Antigua. So while you would have done the energy efficiency capital projects of 50,500 US, the required energy efficiency solar system, which is a 48 kilowatt rooftop PV system, is $316,800. Okay, so you can see the difference in the cost. But the benefits as far as CO2 savings is not significantly higher compared to the energy efficiency. So I'm saying all of this to say that it's really the best thing to do. Focus on the energy efficiency, energy conservation measures, and then move to your renewable energy systems, especially for your, well, for both commercial and residential buildings. Elements of a good energy management program. So you must have policies in place. If you're looking at, moving ahead with an energy management program, what we recommend is to have good policies in place and set up a committee that can actually develop the policies for your organization. And once these policies are developed, you can receive the necessary approvals. And these approvals will come from your CEO, approvals for the resources that you need, financial resources, the human capital, the tools. So all of that, we focus on having the approvals. So the top-down approach where you have the top management involved is very critical, because if not, you may not have access to the resources you need. So a detailed energy consumption baseline, set up a baseline for your organization, set up a hierarchy of needs, the energy measures that you've developed, rank them as far as capital, moderate cost, and low to no energy cost. Start with the low cost or the no cost first. Then you move to the moderate cost, and the savings that you would have derived from the moderate or the low cost, you can move to the capital intensive projects. And finally, you have energy management is incorporated in all designs, and all new designs are reviewed from an energy management perspective. I made mention of that when we looked at the design and construction. Using the energy efficiency building code would be able to help you much more at the design stage. It will cost you less if you do it during the design stage, if you're trying to do retrofits in an existing building. And a good energy management program could save and avoid costs averaging from 30 to 33%, and that is very conservative. Energy represents about 30% of a building's operating costs, and that's a significant amount. So energy efficiency standards are of prime importance to most national energy efficiency initiatives. Just some statistics based on some findings as far as on changing risks and building codes. So I will, in the interest of time, not go through the details, but being able to identify some of the reasons why we should have energy efficiency building codes, energy efficiency standards for our buildings. And this slide kind of sums it up as far as the International Energy Agency. This is what they found in 2019, that only about 35% of energy use is covered by policies. That's at a global level. And as well, 65% of the global energy use is not covered by policies. So we see that we need to really, now that we have the code, use it, put it to use, and to have the benefits and to help save our planet. Because as I said from the beginning, there is no planet B. So thank you very much. And I now hand the mic back to our moderator, Mr. Verne Emmanuel.
Thank you very much, Mr. Norbert, for a very informative presentation. At this time, we would take any questions from the participants. We could use the raise your hand feature so that we can identify any questions, but I would also like to open the floor to Mr. Sherman Francis, the Energy Officer in the Ministry of Infrastructure, Department of Energy, to make any remarks that. Okay. Yes, Vinette. Fontenelle, SLBS. Mr. Gittens.
Yes, morning everyone. I'm Sam Gittens, St. Lucia Bureau of Standards, Metrology Department. Concerning the ventilation for buildings. It's quite common that in modern buildings we use the sash windows or pull-down windows, whereas the casement windows would actually offer, better ventilation. But the problem is the casement windows are more expensive. Although, of course, having them installed will reduce the operational cost of for the building in terms of cooling. So I was wondering whether, mechanisms can be put in place, like through the governments to, apart from duty-free concessions, to put in place price control mechanisms to actually control the markup that the merchants would apply, for those, windows. Because what has happened in the past, like, for example, let's say the energy efficient lamps or energy savers, the duty-free concession, well, it was imported duty-free, but seems the merchants just increased their markup. So perhaps, Mr. Norbert might want to, give some feedback on that. Thank you.
Yes, thank you, sir. That's a relevant question in terms of the what can be done from the policymakers and the public sector can do to assist. So this is one of the things that in Antigua and Barbuda, there is an incentive program in place that if you are ordering any energy efficiency or renewable energy items, that you receive the duty-free concessions. So there is a list that was approved by Cabinet that if you are utilize or buying any of these energy efficiency elements or components, sorry, that you can receive the necessary duty-free concessions. But I must say that there is still a lot of work to be done in this area, as the policymakers are seeking to develop and update policies. I know that you'll be updating your national energy policy very soon. So what we would like to see is a greater uptake and participation among yourselves with the policymakers to develop bold and relevant policies that can support some of what you just said here, or if not all of what you said, because this is the barrier where, the intention is there, the willingness is there, but the constraints as far as the financial constraints and access to the products it remains a concern.
Thanks for that clarification.
You're welcome.
All right. Any other questions or comments? With our good friends from the energy unit, Mr. Inglis, Mr. Francis, you guys like the floor to provide any comments?
Hi, can you hear me?
Yes, Mr. Francis, go ahead.
Great, thanks. Yep. First of all, let me thank Mr. Norbert for this wonderful presentation. It was indeed very informative. Usually, how we did things back then, you want to build, so you just put a plan together and you put a building. But now we can see that actually there's a lot more into just building there's a lot more thought into building than just the building itself. So I hope that we can really get our standards really implemented and controlled on here. And it also highlights the need for our architects and drafters to be well trained in building design and sustainable building. But also I have just a question in terms of renewable energy for building. A few people have told me that adding the PV panels on your roof tend to get the building a bit hotter or keep more heat inside. Is that really true? How does that work?
So I can go ahead, Mr. Emmanuel?
Yes, you can go ahead, Mr. Norbert.
Okay, thanks. Yeah, so again, I'm just going to share my experience and exposure to some of that, what you just said. And statistically, what we have seen is that the opposite is true, in that the photovoltaic array on a rooftop would provide for opportunities to have the roof much cooler than without having the photovoltaic array on the roof. So much so that the code also recognizes, you have vegetated roofs where you can have plants on the roof, vines that are growing up there that can help to provide shading. And in the design of photovoltaic systems, there is a required spacing that should be left between the photovoltaic and the rooftop for ventilation. So an installation that's done properly would provide that ventilation, the air gap between the galvanized and the photovoltaic system or array, so that there is ventilation. So the net effect of having your photovoltaic system on the rooftop is that it should cool your roof and to shield against the direct sunlight from penetrating your roof. So it has to be designed properly, and the net effect is to allow the roof to be shielded from the direct rays of the sun, and in effect to be much cooler.
Great, thanks for that. Thank you.
All right, thank you. We have a hand raised from Henderson.
Hello, all. This was a very good and informative meeting. However, one of the things I wanted to say was, in order to effect change, you have to look at behaviors, and these are things that are not going to be changed easily. If you look in the commercial sector, they usually build, as the presenter was saying, an envelope, and most of them, what they do is they build a big box, whether it is out of glass or it is out of concrete, and then they just fill it with whatever their needs are, whether it's for lighting, whether it's for cooling, whatever it is. I think what should really happen is that people need to look back after the envelope is built to see how it can be reassessed and redone so that it becomes effective. In residential homes, it's becoming the same thing. People build a box and they put a little window here and a little window yonder and a little window yonder. And like somebody earlier said, you usually find a lot of sash windows because that's the cheapest thing that you can get. Whereas if you get casement windows that can open right out, you get more ventilation and so on. So I think that what needs to happen is that people need to look at their respective behaviors. If you look at it not just from the idea of buildings, but if you look at it from the idea of activity, because people can get a used vehicle cheaper, they tend to buy the biggest ones that they can find. If it is all about efficiency, then it has to go into how can we get people to change their behavior so that now they become more efficient. I'll give you one example and then I'll stop. Home by me, I go from room to room during the day to make sure every light that is not being used is off. At night, I do the same thing. That does not come easily. That comes when you have a certain passion and your behavioral mentality is there. So I think it starts from getting people to change their behavior rather than getting people to look and see what is efficient and what is not efficient. Thanks.
Thank you.
Okay, thank you, Mr. Anderson, for that comment. We will have Mr. Kurt Harris and then Mr. Kurt Inglis in that order.
Hi, good morning. I would have a question. In the Antigua experience, because it's something that I notice is an issue, were you able to get insurers, financiers, banks, for example, to build in incentives to enable or encourage persons to go down the route of energy efficiency? Because the cost of energy efficiency from a capital perspective is generally higher. Therefore, when persons look to lending institutions, you find that they generally cannot afford the energy efficiency within the budgets that they have. Is there anything or any way in which you believe, or in the Antiguan experience, you were able to get insurers to reduce, for example, the cost of insurance because a building is energy efficient, and to get bankers, for example, to reduce the interest rates, for example, so as to encourage persons who do go the route of energy efficiency, that there is some benefit that they could realize financially in that way?
Thank you. Thank you for that question. And I must first of all say that Antigua is not yet there in terms of having the insurance companies involved, having the banks involved. There is still a need for applications that support the inputs from professionals as far as being able to, first of all, make the application for an energy efficient home or green building. So generally, we are not there yet. Where we are is there are one or two projects. I made mention of the interpretation center that was just completed. It's not yet open. So we have seen in the public sector, they are demonstrating signs of wanting to move in this direction. So this was a project done by the Department of Environment. There are other incentives as far as what I made mention of with the duty free. But as far as the insurance and what you spoke about, we are not there yet. We still have quite a bit of work to do to get it to that point. As far as what is necessary to get there, I think it's more of the professionals like all of us who are here, the architects, the engineers, to begin to be the ones to design buildings that are efficient, buildings that are considered to be green buildings, and to present to the insurance companies, to the banks. Because when it's done that way, the banks will see, okay, yes, there's an incremental or an increase of a 5% or 10% initial cost. But it's always meant to be looked at based on the life cycle analysis. So you go on the lifespan of the building. The building will last 50 years. My initial cost for the designs, so design a green building design or an energy efficient building design and construction would be X amount more than a conventional building. And this application would demonstrate the savings that I made mention about during the operations of the building. So you see that the payback on that increase, the banks can see that the analysis is done where you can pay back within 3 years or the first year of operations. You pay back for that 5% increase in the design and the construction cost. So this, I think, is where we as professionals must get more and more involved and to submit applications that would demonstrate this type of benefit, taking the life cycle cost analysis, demonstrating to the banks, using the software I spoke about, doing the modeling I spoke about, and submit the applications. Because the banks are really waiting on us and the insurance companies to begin to speak that language and to submit applications that will demonstrate this. But it is possible that we can get there. In Antigua, we are not there yet. There's still a lot of work to be done to get us to this point. But that's a very good observation and a very good point.
Okay, thank you, Mr. Norbert. Mr. Inglis?
Good morning, everyone. I would just like to lend my voice in thanking Mr. Norbert for the wealth of experience and knowledge that he has brought to this presentation so far this morning. I'm actually joining live from COP26 in Glasgow. So where we're speaking on a lot of the things that Mr. Norbert spoke about in his preamble. And one of the things that I'm seeing prevalent here is a cadre of young people who are advocating for the change and the things that we are speaking of, the energy efficiency, the renewable energy, the enhancement in the way that we build and the way that we think. And seeing that, it leads me to think about our young people back in the Caribbean and how we can get our young people to speak in the same way and in the same manner that the young people in the developed countries are pushing their governments to basically drive the changes that we are seeking. I know that the South Louis Community College is doing some work in that field, and I would just like to encourage the Bureau of Standards and all the professionals in it to throw your support behind the college so that we can get our young people to really focus in on climate change, energy efficiency, mitigation and adaptation measures, to get an understanding for the Caricom Regional Energy Efficiency Building Code, so that they can start speaking that language, so that the behavioral changes that we are expecting to see, they can be the ones to really drive that behavioral change. And I would again like to say thank you to the organizers of the webinar today, and the presenter, and you, Mr. Moderator.
Okay, thank you, Mr. Inglis. Do we have any other questions or comments from the audience at this time? Mr. Henderson?
Yeah, one other point I wanted to add was what incentives are there that are driven by government. If I may put forward an example, Barbados has, for the longest while, everybody knows, been at the forefront of energy, well, I shouldn't say energy, but thermal energy in terms of their solar water heating systems. They are now going backwards because they have maxed out, where they've gotten up to the point of, I think, about 99,000 installed solar water heaters. But now that everybody is going to solar PV, what has happened is that they have transferred the benefit where you can claim on your income tax. Because previously, and it still happens up to now, that you can claim on your income tax for up to 10 years for a solar water heater. So they're now putting it for solar PV where you can claim up to 10 years on your income tax for a solar PV system. So I'm saying is, how we also have to look at the policy where, is it a national policy that you can have an incentive to claim for something like this on your income tax, or is there another incentive? I know there is minimal taxes in terms of acquiring and installing a solar PV system, but then there are additional incentives which would soften the blow because of the cost of it and the maintenance and so on. Because it is not just installing the system, but it is looking at the maintenance that has to be done yearly, and as well the mitigation that has to be done if something like a hurricane is coming. So I'm just looking at that particular perspective, if there are any incentives.
Hi, Mr. Henderson.
Yes, you heard me.
Yes, yeah, the last end of your comment.
No, I said the last end I was looking at was, are there any incentives for having a system like this in terms of an income tax rebate, which would cushion the primary outlay of the cost of installing such a system? Because you have to look at the other costs that are there, which are maintenance costs, as well as mitigation costs. For instance, if a hurricane is coming, what do you do in terms of protecting your system and getting it down? I know some people will tell me that there are systems that are geared to withstand certain categories of hurricanes, but I know from experience, especially with Dominica and some other islands that had it, you can lose basically all of your investment, even though it may be guaranteed for a certain strength. So I was just looking at that aspect.
Okay. All right. I think there are some systems in place and some incentive schemes. The question is that, and it is to your question, are those schemes sufficient? Are they flexible? And do they meet all of our requirements in terms of life cycle? Do they address the operation and maintenance issues, because the majority of the incentives are targeted to the initial capital acquisition and the initial capital cost. And I think it is an area that we may need to address and work on in providing an incentive regime throughout the life cycle of the product or the building, specifically targeted to the operation and maintenance requirements. Do we have any other questions or contributions?
I have a question.
Okay, go ahead, Mr. Busby.
I've been looking at videos on energy efficient houses and stuff, and they were talking about there's this push towards passive houses. That's what I think that's what they call it. And when the house is being constructed, they use insulating material within the house to like thermal insulation and stuff. Is that something that is also within the regional energy efficiency building code? Are we pushing towards something like that? And would that even work here in the Caribbean? Like thermal insulation when you're constructing the houses also?
The short answer is yes, and the other answer is yes, it would work in the Caribbean. The code speaks specifically to areas such as mass walls. What we have in the Caribbean is that many people do not pay sufficient attention to the overall design of the buildings. For example, specifically residential buildings. The majority of residential buildings are not designed by engineers or architects, or they tend to use traditional building materials or constructs which do not sufficiently pay attention to the overall energy efficiency of the building. It may, without the proper use of insulation, you may affect or impact on the airtightness of the building and have significant leakage. So even if you were to build a wooden home, if you do that properly with the necessary insulation, you can have a very energy efficient wooden house with air conditioning, with all the other things or amenities that you may wish to include in the modern requirements of our society. I don't know if Mr. Norbert wants to add his input on that question as well.
Well, you did a very good job in the response, Mr. Emmanuel. Just very minimal to say that, you know, in the region, we see that one of the issues that we have is a lot of air leakage in the buildings, as you said. So sealing the joints and the door frames and windows, especially in the fenestration area, we see quite a bit of opportunities for us to reduce the leakiness of our buildings, because it's causing quite a bit of condensation, mold issues in our buildings. And the mass walls you spoke about is very much the approach we've taken to ensure that the buildings are thermally tight. The envelope is insulated. The whole question of air tightness is one of the biggest concerns we have in the region because of the hot temperatures coming into spaces that are air conditioned, causing severe challenges with mold, moisture, and affecting the indoor air quality. So I just wanted to add or to emphasize the need to focus on the air leakage component, which goes unnoticed most times.
Okay, thank you. Mr. Gittins, raise your hand.
Yes, okay, just in St. Lucia, because we have our domestic voltage supply is 240 volts. Many persons wire their homes for 120 volts as well by putting in place a transformer in the building. Based on complaints we've got over the years, we found that that situation is inefficient in that the transformers, you know, tend to consume a lot of energy when they're not loaded. So ideally, one should have appliances in the household that are rated to 240 volts or 240 volts connect directly, you know, to the local grid. Well, probably Antigua doesn't have that issue, but perhaps you could, give, some comment on that, because that kind of configuration where you have dual voltage wire in the homes doesn't seem to be a very energy efficient, mode, and it actually is reflected in a high, electricity bill.
Yeah, so you are correct in terms of the transformers and the additional load. One thing to remember about transformers is that they are on every single second of the day. I remember doing an analysis many years ago in Jamaica at CAST. In those days it was CAST, not the University of Technology. My major project was looking at the improving the losses, and we focus on just changing the efficiency of transformers from somewhere around 91 or 92% to 95%, an increase of just 2 or 3% with these distribution transformers would yield a significant savings because of the fact that transformers are on 24 hours a day and they're consuming energy even when you don't need them. So I think this problem would be because most people would want to buy the appliances from the US. And so because of that, the market that they're using, they're getting the appliances, the accessibility is there. They can get it from the US quite easily. But paying attention to the correct voltage is the best way. And that again is, I would refer to as a low to no cost, just by making the right decision to have the appliances that match your nominal voltage. In Antigua, we don't have that situation because we have the split voltage where you could have two 110 lines in your panel. So there's a split phase where you have 110 and 220 coming in from the utility. So you don't need to have a transformer. But in St. Lucia, again, the awareness to inform, especially residential properties and some commercial properties, to match the voltage with the nominal voltage and the frequency as well. Because I think St. Lucia is 50 hertz, if I'm not mistaken.
Yeah, that's correct.
Yes,
Yeah,
we have
50
yes.
Right. So the efficiency must match the nominal efficiency, which is 50 hertz, and as well the voltage. So it is to educate the public that they should really seek appliances that match the nominal voltage and not just go the easier route and get what is available. So quite a bit of education is necessary so that people can be guided accordingly to make the right decisions. The choice to buy the right equipment in the first place, because you're spending the money, spend it buying the right thing in the first place, and it's more efficient than buying a transformer. Transformers are energy guzzlers. And so the efficiency ratings in the code, there is a section that looks at the efficiency rating of transformers. And when you look in there, you will see that we have gone up to 99% efficiency. I mean, two or three decades ago, transformers at 90% efficiency were considered to be great transformers. But where technology has taken us now is that you can now get transformers that are up to 99% efficiency. But if you can avoid it in the first place, that's always the best approach. Because the energy that's not used is the most valuable energy.
Okay, thank you, Mr. Norbert. Do we have any other questions or comments from our audience? We noticed a few persons have joined us recently. Any questions or comments? Go ahead, Mr. Francis.
Can you just give me a comparison? Let's say a 3-bedroom domestic house built in the conventional manner, and the same house built with energy efficiency.
Mr. Francis, you're a little muffled. Could you?
Can you hear me better now?
A little bit.
Yes. Can you please give a comparison in terms of a house, a domestic house, 3 bedrooms, built conventionally, and one built with energy efficiency design in mind? What would be typical in terms of energy consumption? Can you tell me what the difference might be?
Did you hear that question, No, but Mr. Francis, is your question a comparison between a traditional 2-bedroom house versus one built with using the code?
Correct. Yes.
Right. Okay. So in the code development, we did that analysis and we tried to stay away from doing comparisons using cost of construction. We did those analyses using what we call the energy usage index, and we were able to demonstrate to our target audience that our comparison is using what we call the business as usual scenario, which is your traditional building, and comparing it with the application of the code using the new building, using the application of the code. The specific area that we would compare is the energy usage index, so which would be able to have a more succinct comparison. Why we stay away from construction costs, right, is that construction costs can vary based on the actual finish of a building. But the energy usage, when we now start to do the comparisons of your fenestration, the efficiency of your windows, your doors, your mass walls, your airtightness, you're able to then see how the consumption of that building or occupied space, how it varies from the traditional context. And the use of the code significantly reduces the energy per square meter as compared to a traditional building. Okay, thank you. All right, so we're coming up to 12 p.m. If we don't have any further questions or comments, okay, I see Ms. Joseph.
Hi, Mr. Emmanuel. Thanks. So I joined a little late, so I'm not sure if this was addressed, but I tried to pick up a bit while the presentations were going on. I am interested in whether, now that we have the code and promotion, of course, happy Energy Month to everybody, whether we would have any type of project or pilot where we can demonstrate a build based on the code, and if it is, the cost and feasibility of purchase for the average consumer, or even if it's not the average consumer, but maybe it's at a commercial level, but whether we can see any type of tangible outcome from application of the code by seeing or having a real build or building based on the code.
Well, that is something we can do, which is to go out and basically document a code compliant building or your typical code compliant house. We note that the current plans for the redevelopment of UNRWA International Airport have followed the use of the energy efficiency building code. And so it would be, on completion, it would be a building which would seek certification to having met green building standards and being code compliant. We have seen the interest from the St. Lucia Institute of Architects and the Association of Professional Engineers in the use of the code, but we have to date not had any specific buildings which have been certified as being built to the code. But it is something that can indeed be pursued in terms of documenting an actual building which would have used the energy efficiency building code as its model. And adding to what was probably suggested by Mr. Harris earlier, we can, in using that model, then approach insurance companies and banks to close the loop, if you want to call it, in having a sustainable model in the use of the code.
Thanks.
Right. Okay, any other questions? I notice we have persons joining. I assume they were following us on YouTube earlier. Okay, well, if we have no more questions or comments, I would like to thank Mr. Norbert for agreeing to be our facilitator and presenter today. I would like to thank you all for attending this webinar, and I will give Mr. Norbert the last words to say thank you to us all.
Yeah. Well, thank you again, Mr. Emmanuel, and you have been a champion in this drive from the time we started working together in 2017 in developing the code. And I just want to encourage you to continue what you're doing with, being an advocate for energy efficiency in buildings, standards for buildings, recognizing the significance and importance, the low-hanging fruits that are in our buildings. So I just want to take this opportunity to congratulate you and to encourage you to keep fighting the good fight. Before I conclude, I want to just go back to something that Mr. Harris mentioned about the youth. The future belongs to those who invest in the youth, and there are many opportunities.
Just to interrupt, that would be Mr. Inglis. You have the wrong cut.
Oh, sorry. My apologies, and thank you for the correction, Mr. Inglis. Yes. So thank you for remembering and touching on the youth, because the future really belongs to the youth, and there are many ways you can incorporate programs. You can have things like treasure hunts in your respective schools, an energy treasure hunt where they're involved, and we've seen tremendous success from that type of thing. Apart from the curriculum, developing energy efficiency measures in the schools and teaching them, but activities like treasure hunts, energy treasure hunts, can really help to bring about this awareness and to bring about the change that somebody else spoke about, the change management with the behaviors. At home, having incentive programs where the entire household is involved in the process. My example at home, when I bought my home in Antigua, my utility bill was in the region of $1,200. But through the energy efficiency interventions, we have managed to take it down to $400. So that difference is based on retrofitting the air conditioning from conventional to inverter units, LED lighting, changing the water heater from electric to now a thermal water heater. So keeping them involved in the process, keeping the youth involved and engaged, because they're the ones who will police and ensure that we do what we say we will do to protect the future for them. So I just want to echo that sentiment, where we include the youth and let them be part of the process and have a say in what is going on. So thanks again to all of you who are here with us, and you are the ones to make that change. You're the ones to begin the pilot projects. As customers come to you, promote the code, let them know about it, that it exists, and that you can help them to guide them towards actually using the code. Because we are in a decade of action. The resources that we need are being made available. There's a new partnership that was developed with the AOSIS countries, the SEEDS, and IRENA, where we're looking at tremendous amount of finance that will be flowing through the region again, coming out of COP26. So let us position ourselves to have good policies in place, good habits in place, so that we can really make that change. The 2030 region, the targets that we have set, we have the technology, we have the finance, and the capacity is being built right now to get us to 2030 successfully. The issue about beyond that is where we should be focusing on new technology and new policies as well to continue that journey to 2050 and beyond. So thank you for having me. It's always a pleasure speaking with you guys, and just keep on doing the great work. And no effort towards energy efficiency and towards a sustainable future is done in vain. So let's just keep on doing what we're doing. And thank you so much for having me.
Okay, thank you, everyone. Thank you to the persons joining online, other NSBs, and the Cross-Q Secretariat. Thank you. Happy Energy Awareness Month.